Let's see quite a simple example to realize the technique of linearization. The problem is the liquid level control. So this problem is known from an example which I mentioned before, and these are the nonlinear equations which we got. So this term here is the nonlinear equation f with the two arguments of h and u. And this equation here, this nonlinear equation here is j, h, and u. And there is a technique of linearization to how to get the linearized approximation system of this nonlinear system at the operating point. So the first step is to get the operating point. At the operating point, h bar dot is 0 because the operating point should not move, should not change. So if I write the first equation h dot equal to f hu equal to 0, then we are going to get a direct correspondence between h and u bar. This is what I mentioned here. And the second step is to do the derivatives. df over dh, this is the value of a. df over du, we are going to get b. dj over dh, we are going to get c. And dj over du, we are going to get the value of d. So first we have to take the derivatives, and then we have to put the values of the operating points to the expressions of the derivatives, and then we are going to get given values for a, b, c, and d. And this is the linearized system of equation that we get for h tilde, u tilde, and y tilde. But what does it mean in this case? In this graph, I put h bar, so this is the operating point, but the linearized system of equation is valid if our liquid level is changing a little, like this one. So this level here is something like h bar plus h tilde, for example, and of course this value is also, but with a negative sign. So this linearized equation, which we got at the end, is valid only for this movement, only for this very small change. So u tilde is the value of the input signal which is added or subtracted to the value of u bar. And finally, y tilde is the value which is added or subtracted to the value of the output at the operating point y bar. So this is the meaning of the linearized equation. So it's very, very important to recognize that usually we need an operating point, and the linearized equation we get at the end of the linearization technique is the equation which varied only in the vicinity. And these are the equations we need for controller design in the future work.